The first principle is that you must not fool yourself, and you are the easiest person to fool. If you remember one rule from me, let it be that. It is 1974. I am standing at a podium at Caltech. Graduation day. Hundreds of students in caps and gowns, their families in the audience, ready to celebrate years of hard work. I look out at their faces, eager and optimistic, ready to go out and do science, real science. I opened with a joke, got a laugh. Then I got serious. And I am about to tell them that a lot of what passes for science looks like science, but it is missing the one thing that makes science real: integrity. Because I had learned the hard way how easy it is to fool yourself. After World War II, something strange happened in the South Pacific Islands. During the war, American planes had landed on remote islands, bringing supplies, cargo, food, medicine, equipment, clothing, things the islanders had never seen before. It must have seemed like magic. The Americans built airstrips. They set up control towers. They wore uniforms and headphones. They waved flags and lit fires. And then the planes came down from the sky, full of incredible things. Then the war ended. The Americans left. The planes stopped coming. But the islanders wanted the cargo back. So they did something fascinating. They built runways out of bamboo. They carved headphones from wood and coconut shells. They waved landing flags made of sticks. They lit signal fires along fake landing strips. They sat in wooden control towers and performed all the rituals they had seen the Americans perform. They did everything right. It looked exactly like an airfield. Every detail was copied with remarkable precision, but no planes landed. They had copied the form perfectly, but they had missed the substance. They didn't understand why the planes had come in the first place. I called this cargo cult science. And here's the uncomfortable truth. It happens everywhere. In labs, in universities, in research papers published in prestigious journals. People follow all the forms of scientific investigation. They collect data. They write equations. They publish papers. It looks like science. It sounds like science. Colleagues nod and cite the work. But something essential is missing. What's missing is scientific integrity. And the scary part? Smart people do it. Brilliant people do it. People who genuinely believe they're doing real science. That's what makes it dangerous. See, the problem isn't fraud. Fraud is easy to catch eventually. The problem is self-deception. The problem is fooling yourself while thinking you're being rigorous. Let me give you some examples. In those years, there was a lot of excitement about extrasensory perception, ESP. The idea was that people could read minds, predict cards, or move objects with their thoughts. Researchers ran experiments and they published results. Some of the numbers looked impressive, and people wanted to believe. But when other scientists tried to reproduce those results, something always went wrong. The effects grew weaker, the numbers did not hold up, and the conditions were never quite the same. The original researchers had followed the outward forms. They had test subjects, control groups, and statistical analysis. It looked scientific, but they had not bent over backwards to prove themselves wrong. They had not considered every possible way they might be fooling themselves. They had not reported all the details, the failures, the anomalies, the things that did not fit. That is the cargo cult. The runway looks real, but the planes do not land. Now let me tell you about a case that really stuck with me. It involves rats. A meticulous researcher did experiments with rats running through mazes. He was trying to figure out how rats learn. Do they follow visual cues? Sounds? Smells? He was more careful than almost anyone before him. He started eliminating possibilities one by one. First, he thought maybe the rats were following the paint on the walls. So he repainted. The rats still knew where to go. Then, he thought maybe they were smelling something. So he used chemicals to mask the odors. Still, the rats found their way. Then he realized they could hear the floor. Different parts of the maze made different sounds when the rats ran across them. So he put the maze on sand to muffle every footstep. Finally, with all those cues eliminated, He could actually study how rats learn. He figured all this out through painstaking work. He published his findings. He explained exactly what you had to control for if you wanted to study rat learning properly. And then something remarkable happened. Nothing. Nobody paid attention. The next generation of researchers kept doing maze experiments without controlling for any of the things he had discovered. They kept publishing papers. They kept getting results that could not be reproduced by other labs. They kept wondering why different laboratories got different results. Why? Because controlling for all those details was hard. It was expensive. It was time-consuming. It was easier to just run the experiment the old way and hope for the best. That is cargo cult science. The researchers were not dishonest. They were just cutting corners. They did not even realize they were cutting. They were fooling themselves. His work should have been the foundation of everything that came after. Instead, it was forgotten. People cited each other's flawed studies instead of going back to the hard work of doing it right. I told the graduates at Caltech, if you are doing an experiment, you must report everything that might make an observer think your result could be wrong. Not just what makes you look good. Everything. The method, the conditions, the anomalies, the failures, the things you tried that did not work, the data points that do not fit your theory. If there is a flaw in your reasoning, you need to find it before someone else does. And if you cannot find one, you need to look harder. That is what scientific integrity means. It is bending over backwards to show where you might be wrong. If you are finding this valuable, the real stories behind how science actually works, subscribe. There is more coming. Here's another example that bothered me. This one hits closer to home. It's physics. You've probably heard of the Millikan oil drop experiment. Robert Millikan measured the charge on an electron, one of the most important measurements in physics. He won the Nobel Prize for it. His work was considered a triumph of careful experimental technique. But here's the strange part. When you look at the history of measurements of the electron charge after Millikan, the values do not jump around randomly the way you would expect from independent measurements with their own random errors. Instead, they creep. Each new measurement is a little higher than the last, then a little higher, then a little higher, slowly, steadily drifting toward the value we accept today. Why? Because researchers were comparing their results to Millikan's. He was the authority. And here is the thing. Millikan's original value was slightly off for reasons that only became clear later as techniques improved. But nobody knew that at the time. So when later researchers got a number that was too far off from his, they assumed they had made a mistake somewhere. They looked for errors in their own work. They adjusted their methods. They threw out data points that seemed anomalous. They were not lying. They were not consciously faking results. They were simply unconsciously biasing their work toward the expected answer. They trusted Millikan more than they trusted their own data. That is the most dangerous kind of self-deception. You do not even know you are doing it. The only defense is extreme honesty, radical transparency, reporting everything, even when it makes you look bad. That is the brutal rule. You have to be your own harshest critic. You have to attack your own ideas more viciously than any opponent would. You have to assume that you are wrong until you have exhausted every possibility. This is not natural. It goes against every instinct we have. We want to be right. We want our work to matter. We want the beautiful theory we have spent months developing to match the data. But wanting something to be true has nothing to do with whether it is true. Because the universe does not care what you want to be true. The universe does not care about your reputation, your funding, your career, your ego. The universe just is what it is. And if you fool yourself, you will never find out what is actually real. I have seen brilliant people waste years on ideas that felt right, but were not. I have seen careers built on results that could not be replicated. I have seen entire fields chase ghosts because nobody wanted to be the one to say the emperor had no clothes. The forms were all there. The papers, the citations, the conferences, the awards. But the planes never landed. Science is not about looking scientific. It is about finding out what is true. And finding out what is true requires a kind of honesty that most people find uncomfortable. You have to admit when you do not know something. You have to admit when your beautiful theory does not match the data. You have to report the experiment that failed, not just the one that worked. You have to tell the whole truth, even when it is messy and inconvenient. That is not just a rule for scientists. That is a rule for anyone who wants to understand anything real about the world, because we all fool ourselves every day about big things and small things, about who we are and what we want and what we believe. The question is whether we have the courage to catch ourselves doing it. I told those graduates in 1974 a simple thing. I said, the first principle is that you must not fool yourself, and you are the easiest person to fool. After you've learned not to fool yourself, it's easy not to fool other scientists. You just have to be honest in a conventional way after that. I explained what I meant by integrity, not just avoiding lies, but bending over backwards to show how you might be wrong. And then I told them, because I couldn't help myself, that they shouldn't fool the layman when talking as a scientist. But I wasn't trying to tell them what to do about cheating on their wife or fooling their girlfriend. I said I'd leave those problems up to them and their rabbi. The audience laughed. I meant it. But that first part, not fooling yourself, that's the hard one. That's the one that takes a lifetime. I spent my whole career trying to live by that rule. I didn't always succeed. Nobody does. I've caught myself wanting to believe something so badly that I ignored evidence. I've felt the pull of self-deception. But I tried. Every day, I tried to catch it before it caught me. And I'll tell you this, every time I caught myself believing something because I wanted it to be true, every time I forced myself to look at the evidence I was ignoring, every time I admitted I was wrong when I desperately wanted to be right, that's when I actually learned something. That's when I got closer to understanding how nature really works. That's when the planes landed. I was Richard Feynman. I won the Nobel Prize for quantum electrodynamics. I worked on the atomic bomb at Los Alamos. I spent decades teaching students how to think. And if there is one thing I hope they remember, it's this. Don't fool yourself. You're the easiest person to fool. Everything else follows from that. If you want more stories like this, the real moments behind how science actually works, subscribe.